Hello, I'm Mr. Wilson, and today we're going to be talking about object-oriented programming and inheritance. The first thing we need to talk about is what is object-oriented programming. So an object is simply a thing, like an enemy spaceship or a dragon. It doesn't matter what the thing is, but they all have something in common. They all have properties, things that define what exactly that object looks like, behaves, etc. So for example, in this case, our enemy ship might contain a property for height. The dragon might also contain a property for height. Perhaps our enemy ship contains a property to dictate how much health he's going to have. Perhaps the dragon has a property to dictate how much fire he can breathe. What makes an object useful is the fact that you can have multiple versions of it. Once you define what exactly it is that makes an enemy ship, once you define what it is that makes a dragon, you can use that definition to create as many dragons or as many enemies as you want. Now, the key thing to take away from this is that you can define enemies and dragons in any object in two different ways. Either the property can be unique. So in this example, we see that an enemy ship might have a height of this much, whereas this enemy has a height that's much less, and this enemy has a height that's much more. So these values can be unique. Over here with the dragon, we see that this dragon is this tall, which is the same height as this guy, which is the same height as this guy here. No matter what the enemy is, they all have the same height. When an object has a property that is the same for all instances, that is to say, if all of the objects created with that template all have the same value, in this case height, we say that that value is static. When an object has a unique value for each of its instances, in this case height is different for each one of the enemies, we say that that property is not static. Now what's nice about this is if we have our enemy ships and they each have a certain amount of life associated with them. So this guy has 1 unit of health, this guy has maybe 2 units of health, and this guy has 3 units of health. Because these units were not static, they can each have a unique health value. If I made health static, then that means when I attack one enemy, they will all feel the hit. So to illustrate that, we can do it like this. If I made health static, then that means they all have to have the same amount of health. So if I were to attack this enemy and remove one of his health units, then this guy would also lose a health unit, and so would this guy. In fact, it's probably more accurate to draw static health units like this. You only have one set of health for all of your enemies. So if I shoot this guy, you lose a unit of health. If I shoot this guy, he loses another unit of health. And when I shoot this guy, the last unit of health is lost, which means now all enemies are dead. Using static properties makes sense in some situations and not in others. In this example of health, we obviously wouldn't want all of our enemies to have the same units of health. They wouldn't share health. Each enemy would need its own health value. So we would ensure that the health property was not set to static. In the instances of our dragons, we had the height property of each dragon all set to the same. If you were making a video game, perhaps you wanted all of your dragons to be the same size. Perhaps you don't want them to be the same size. So in this case, it's a judgment call. If you want all of your dragons to look the same, then you can make the height property static, and they will all have the same height. So now that we have an understanding of what a static and non-static property is, and now that we understand that objects can have properties that define what they are and what they look like and how they behave, now we can start to talk about how to actually create one of these objects. In C#, to create an object, you create something called a class. In this case, we could create a class named Dragon. And what that class is it's a recipe. I often use the analogy of an apple pie to describe classes. So if you think about an apple pie is an instance of an apple pie object. In order to create the apple pie, I had to use a recipe. The recipe tells me how much sugar and how much eggs and how many apples to put into the apple pie. Using this recipe, I can create as many apple pies as I want. In this example, the recipe is the class. And the class defines what exactly an apple pie should look like, how it should taste, what its sweetness level is. Going back to our dragon, the class called Dragon contains all of the definitions for what makes a dragon what it is, how much fire it can breathe, how much life it has, what its height is. All of that is defined by the dragon class, or the recipe for a dragon. Then I can use that recipe to create as many dragons as I want. So now that we have an idea of what exactly an object is and how we use classes to create them, we can start talking about how to write the actual code to do these things. All right, so let's get into the code and talk about how to create classes and then how to use those classes to create instances of our different objects. In this example, we'll be creating a sort of game, and we'll be creating enemies. So here is the main method for our game. All of the game logic will go in here. But what we want to do is create some enemies for this game. You can see that the main is part of a class called program. What I'm going to do is create a new class down here for my enemies. Class has to have opening and closing braces to tell it where the code that defines that enemy begins and where that code ends. At the top of the enemy class, I'm going to write some variables, which will be my properties. They will define what this enemy is and all of the other stuff about him, like his health and things like that. Let's go ahead and start with a health value. And we'll give him an initial health value of 3. And perhaps we give him some magic power as well. And we'll give him 10 units of magic. Going back to the example that we saw earlier, perhaps we give him a value for height. And maybe a value for width. Pretty much anything that you need to define how your enemy works or behaves will be set up as a variable at the top of your enemy class. In order to create an enemy, I'm going to need something called a constructor. A constructor works sort of like a method, except it has to have the same name as the class itself. So in this case, it's going to be enemy. A normal method would contain a chunk of code, and you could call it anytime you want. A normal method would have to have a return type. In this case, a constructor looks like a method, but you'll notice that it is lacking the return type. It doesn't specify if it's going to return an int, a string, or in some cases void if it didn't return a value at all. In this case, no return type at all is specified, because what the constructor does is it returns an instance of the object. The constructor is responsible for assembling the object. In computer terminology, we refer to this as instantiation. So when I create a new enemy ship, I'm going to call the constructor and it will put it together for me. If I want to use default values, like the ones that I have specified up here, then I would just take no arguments. However, if I want the programmer to be able to specify how much health this enemy will have when the object is created, I can create parameters in my enemy constructor that allow me to accept those values. For example, I could create a parameter for health and perhaps another parameter for magic. When the programmer instantiates our enemy object, he'll have to specify how much health and how much magic this enemy will have. In this case, I'm going to move the value that they specify out of this parameter list and move it into the variable that I created up here. So I'm going to say this health. Which one? The one that was defined in this class. This health equals health. This is a little confusing to new programmers, but the way this is read is this health is the one that was defined in this class, and the one that does not have this is the local one that was defined by the parameter list. So what I'm doing is I'm saying this health is going to equal the one that was specified in the parameter list. And I'll do the same thing for magic. All right, I now have a very simple class that defines what an enemy is. In my main, I can now instantiate that class. Going back to the apple pie analogy, we can think of the enemy class as being the recipe that defines what an enemy is. I'm now going to use that recipe to build an enemy. I'm going to call this enemy ship Joe. As with any variable, I have to specify the data type first. Is Joe an int? Is Joe a string? In this case, Joe is an enemy. Joe is going to equal a new instance of the enemy class. What I'm doing here is calling the constructor for the enemy class. That's what new does. It says, create a new enemy object by calling its constructor. The constructor takes two parameters, health and magic. I'm going to start this enemy off with 5 units of health and 7 units of magic. Now that I have an enemy ship, I can create as many of these as I want. I'll create another enemy called Bob. He also is going to use the new command to call the constructor. And the constructor requires the 2 parameters for health and magic. Bob is only going to have 3 units of health and 2 units of magic. Now I can do whatever I want, whatever other code is necessary to play the game. If at any point I want to reduce some of Joe or Bob's health, I can do it like this. Joe.health minus minus. That would remove 1 unit of health from Joe. Here we see that we have an error. It says health is inaccessible due to its protection level. If I look at the variable for health, I can see that it's just an integer, which means that it exists only within the confines of this class. Yet I'm trying to access the health variable from a completely different class, in this case, the program class. This is possible, but I have to give the computer permission to do it. And the way we do that is by specifying the keyword public. Now, health is public and can be accessed from anywhere. If I tried to do the same thing, perhaps this time with Bob, I'm going to eliminate some of Bob's magic. I want to say Bob's magic equals whatever it was before minus 2. I'm going to take 2 units of magic away from him. That's all the magic he had. I notice I get the same error here. Magic is inaccessible due to its protection level. If I want to use magic from outside of this class, I have to specify it as public as well. There are other visibility modifiers, but they're beyond the scope of this lesson. To prove that this is all working, I'm now going to output the values of these variables to the console to see what they now are. I'm going to say console.writeLine, and I'm going to tell it to print how much health Joe has. While I'm at it, I'll tell it to write out how much magic Bob has. Let's go ahead and run it and see what this does. Here you can see that Joe started off with 5 units of health, and then I subtracted one of those units. 5 minus 1 is 4. Bob started off with 2 units of magic, but then I subtracted 2 units of magic. 2 minus 2 is 0. Here you can see that you can create individual objects. Both Joe and Bob are both enemies, but they have very different properties. Joe had more health than Bob did. Joe had more magic than Bob did. I'm able to use the health and magic of each object individually without affecting the other. When I subtracted health from Joe, Bob didn't lose any magic. He started off with 3, and he still has 3, even though Joe lost a unit of health. And when Bob used some of his magic, Joe's magic wasn't altered. Joe started off with 7. Even after Bob lost 2 units of magic, Joe still has his 7 units of magic. Just to illustrate the static concept, let's say that that Joe and Bob are members of some kind of a tribe, and the tribe only has so much magic, and all of the tribe members have to share that magic pool. In that case, I would make magic static. Here, this means that any enemy will have to share these 10 units of magic. Since all enemies have to share magic, I can't have a parameter that sets a specific value for magic during instantiation. Here's the reason why. When I create Joe, I'm defining what exactly Joe is going to look like. He's going to have 5 units of health. There's no reason to establish that he has 7 units of magic because they all have to share the same. I can't allow Joe to have 7 and Bob to have 2. They're not allowed to have different values since they all share from the same pool. Therefore, I have to eliminate this parameter for magic. They no longer get their own version of magic. They all share from the magic pool. Now that I have eliminated that parameter for magic, I have to remove it from the constructor as well up here when I call the constructor. All right, so let's see what these modifications look like. I've modified the constructor, which now only takes 1 argument for health. When I create a new enemy object, I specify just its health, and that enemy will get that amount of health. In this case, Joe still has 5 units of health, and Bob still has 3 units of health. They both are going to share the 10 total units of magic. Here, Joe is going to use some magic. Bob wants to use some magic too, but Bob doesn't have his own unique value for magic. That's why we have an error here. It says, magic cannot be accessed with an instance reference. Qualify it with a type instead. So here, Bob doesn't have his own magic to draw from. He has to draw from the tribe's magic. So instead of saying bob.magic, I just say the enemy's magic, enemy.magic, because how you read this is that you are drawing from the enemy tribe's magic. So here, all enemies are sharing the same amount of magic. So take some magic away from all of the enemies, not just Joe, not just Bob. Take it away from all of the enemies. Here, if I want to see how much health Joe has, I can do it the same way I did before. Joe.health. How much health does Joe have? If I wanted to see Bob's health, Bob.health. How much health does Bob have? What if I wanted to see how much magic all of the enemies have? I can't just say print out Joe.magic because Joe doesn't have any magic. Only the enemies together have magic. So I'm going to refer to the enemy class. Console writeline, how much magic do all of the enemies have? Let's run this and see how it works. 4, 3, 8. Let's look where those values came from. Joe starts off with 5 units of health, and then I subtract 1 unit of health. 5 minus 1 is 4. Then I print how much health Bob has. Bob started off with 3 units of health, and Bob's health never changed, so he still has 3 units of health. The last value, 8. The last value to print to the screen was how much magic do all of the enemies have. All of the enemies started off with 10 units of magic, but then I subtracted 2 units of magic from all of the enemies. 10 minus 2 is 8.